In this video, I'm going to show you a program for converting a covariance matrix to a correlation matrix. You can convert two covariance matrices to correlation matrices within the program, and the program will then calculate a difference matrix between the two. The program is useful to evaluate model fit for SEM models that SEM software does not report traditional global fit indices for. The difference matrix is in units of correlations, so it's reasonably interpretable. Okay, let's go down and get the program. It's down here under Cov to Core, and when I click on it, the input interface for the program opens up. In the description box down here is the description of how to use the program. I'm not going to go through those instructions because I'm going to be showing you the program here. Down here is an input box that we have to provide certain information to in order to run the program in R. I've structured the program so it'll be as easy as possible to copy and paste output from M+. In this video, I'll go through the process based on M+ output. The M+ analysis I use to illustrate the program fits a latent quadratic model using the LMS option in M+. As you will see, M+ only gives you very limited fit information, and I find it helpful to calculate the predicted and observed correlation matrices between the input variables and their differences to help me get a better sense of model fit. Okay, for the M+ program I'm going to show you, I have a total of 8 variables that I've input, and that's what I put in up here. Up here I have to give the variable names. I'll show you a way of doing that from the M+ output. And then I have to specify the number of matrices that I'm going to be analyzing, either 1 or 2. In this case, I'll show you 2. Okay, let me go get M+. Here's the program that I ran, and here is the model fit information that M+ provided me. And you can see that all it gives me is the log likelihoods and the information criteria for fit. We don't have the CFI, we don't have a chi-square, we don't have an RMSEA, nothing like that. The program also doesn't allow for modification indices, so I don't have those, nor do I have standardized residual tests. My fit information is pretty limited. So the strategy I'm going to use is I'm going to look at the predicted correlation matrix for the 8 variables that are in the model, and I'm going to compare that to the observed correlation matrix for the 8 variables. Okay, I requested on the output line that M+ give me residual output, so let's go to that section of the output and see what we have. Here it is here. Now M+ gives me the estimated model means, and I'm scrolling down now, and I get the residuals. There's the estimated covariances, and that gives me the residuals for the covariances. Now these residuals are the difference between the predicted and observed covariance matrices, but they're very hard to interpret because they're influenced by the metrics of the variables involved. And unless you have a really good sense of the raw metrics and a good sense of what a covariance is, this is very difficult to interpret. It'll be easier for me if I put it into correlation units, but M+ doesn't give me the correlations. So I'm going to go back up here, and I'm going to take this covariance matrix for the 8 variables, and I'm going to input it into my program. And my program wants it in the form of a lower triangular matrix, which is what M+ gives me here. So the first thing I'm going to do is I'm going to take the labels up here and give those to my program when it asks for the names of the variables. So I'm going to take these 3 names here, and I'm going to put them at the end of these 3 names. And then I'm going to put a comma between these because my program wants comma delimited label names. I'll bring these over. and I don't comma delimit the last one. And then I'm going to highlight these and copy and paste them into my input box. So I'm going to come over here and I'm going to hit Control V and they'll paste. Now I got weird spacing between all these, and I could go through and eliminate those spaces, but I don't need to. It turns out my program will adjust to it. So I usually just leave these exactly as they are, and my program will ignore all the blank spaces. Okay, once I've put in the number of variables, the variable names, and the number of matrices, I click Register Input, and my program is then going to generate the R syntax that's needed to convert the covariance matrix to a correlation matrix. What you have to do before executing the program is to put the lower triangular covariance matrix here. I'm going to copy and paste that from M+. Actually, we're going to put it up here because that's the first covariance matrix, and I'll put the second covariance matrix down here. Okay, so I go back to M+, and I'm going to be copying these numbers and pasting them into my program. But I need to get the rest of this covariance matrix that's reported down here up here so that I have a full lower triangular matrix. So what I'm going to do, I'm going to use a trick. I'm going to hold the Alt key down. I'm going to then drag the mouse across those. And then I'm going to hit Control C to copy it to the clipboard. And then I'm going to come over here and I'm going to place the cursor where it needs to be. And I'm going to hit Control V and it'll paste those numbers there. Now again, there's weird spacing between all of this, but my program can handle that. All I need to do is copy and paste these numbers here. Now to do that, I have to use the special pasting trick where I hold down the Alt key and then I drag the mouse across these numbers. And then I hit Control C to copy it to the clipboard. And then I come back to my program and I'm going to replace this line. So I delete it and then I hit Control V to paste it. And there it is. I'll go ahead and delete these spaces. I don't need to. And because this box is narrow, some of this will wrap around and it'll look weird like it does here. But that's okay. My program can handle that. And all I have to do is paste it in the way I've showed you and we're fine. So this is the predicted covariance matrix for the model that I fit. Next, I'm going to go to the M+ output and find the observed correlations and paste them there. So going back to M+, I'm going to go up to the beginning of the output. I've got to get the covariances. Even though it gives me the correlations to use this program, I have to paste the covariances. So I'm going to again hold down the Alt key and drag across these guys. I'm going to hit Control C to copy that to the clipboard. I'm going to place the cursor up here and hit Control V, and then it's going to paste. And then I'm going to hold the Alt key down. I'm going to copy these numbers. I'm going to hit Control C to copy it to the clipboard. I come back to my program. I'm going to delete this line and hit Control V to paste, and then it pastes it all. And at that point, this is the R syntax I need to run. So I'm going to copy it to the clipboard. I'm going to open up R. I'm going to hit Control V up here, and that's going to paste the syntax I generated, and as it pastes, it will execute. Okay, the output is in blue, the programming is in red, so if I go to the top of the output, The first thing I get is the first matrix converted to a correlation matrix. That's there. Then the second thing I get is the second correlation matrix that has been converted from the covariance matrix. And then here's the difference between the two matrices. And all of these should be 0 in principle. And I can see I've got some discrepancies in there. All of these are in correlation units. These are directly interpretable. So like the difference between this correlation, the predicted and observed correlations, was minus 0.027 correlation units and so on. And I can see that I've got a pretty good fitting model here. All the discrepancies between the predicted and observed correlations are pretty low. And that helps me to evaluate the model fit. Okay, I'll close this and go back. I'll scroll up to the top, and that's it. Thanks a lot.